a conversation, an opportunity with Adamy, and we managed it today. I'm very happy with your schedule. You managed to get an appointment, and I was happy because talking about Vergraf, we talk a lot. We're growing more and more in Brazil and abroad. But now to talk to someone who already has ownership, with someone who helped Vergraf at the beginning, when it was still there cutting the stone. Adamy was one of the collaborators. I don't know if the first or one of the first Adamy to be together with Vergraf.
I looked up the date in May 2021 that I started using it.
May 2021. Oh, that's great. Look, it's already come with an important date because we say that Vergraf is 2 to 3 years old. So see if you've already put a date on it. It was there in the
first roll I got my hands on, I took to a construction site to try it out. It was in May 2021 when Manuel was here in my office. Then he had 2 rolls in the car, and I said, give me one and I'll use it. Then he had no doubt. He took it. He wanted to give me his eyes. Let's talk with just one.
Nice. And I knew Manuel at the time. Manuel was almost all Vergraf, the one who kicked, headed, and there was a period like that. Today, Vergraf is incredible with hundreds of people already working and the factory growing more and more. But I want to talk a bit about Vergraf. But first, I want to ask you a few questions so you can get to know it. Who is Marcus Adamy? Which company is Marcus Adamy? What is Marcus Adamy's specialty? Where is it? I know this is Novo Hamburgo, but Novo Hamburgo is the headquarters. It's my neighbor here, but it's all over Brazil. I don't think the work is just regional, is it, Adamy? Explain a little about the company.
I'm a designer, a civil engineer who graduated in 1997, specializing in high-rise buildings. My specialty is structural calculations, and I've focused a lot on high-rise buildings. My office also develops electrical, plumbing, and fire prevention projects, and we come with this engineering package that complements the architecture. Some call them complementary projects, others call them engineering projects, but my office only does projects. We end up visiting construction sites, giving advice, going to construction sites. I used to have a consultant, but not anymore. But our focus here is only on projects, and we serve the whole of Rio Grande do Sul, but we have work in Rio de Janeiro and São Paulo. You don't have to go there because you're a designer. If you have a question, send us a video. But what's on paper, if it's followed, that's fine, right? This globalization has no distance we can travel. That's an obstacle, right?
To be able to reach everyone, maybe even countries.
Some people don't even know we're from the south. They think they're doing a project. Just now I was talking to an architect from Campinas, so she asked, can you come here? I have a question. No, wait. I'm judging myself, sir. I can't go there. She sent me a video. I replied straight away, and it was done. But a lot of people have that anxiety. They need to come here. I can't explain it to you. So you make a video. We understand what your problem is. That's settled, right?
That's it. And Demi, I don't know if...
You're not... No obstacle, right?
I don't know if people will realize this, but your calmness and ease in solving problems. Come on, make a video. It's like this, like this. Yes. With our work at Vergraf, the work I've seen you do, and you explaining how to use Vergraf, always with this objectivity, you don't need to complicate things. You don't need to beat around the bush. You know a lot. This shows your professionalism. You know what you're doing very well. Well, project here, explain there. And anyone who masters an area that from the outside looks easy, that's because they're very good at it. And I have that vision even when you say it, and now was an example of that. So, you know, I'm a fan of yours. I don't just say, oh, you're the best designer I know, you're the best calculating engineer because I followed your work here. I really do. Not just because of the way you twist things, but because of the way you speak.
Thank you. I appreciate it. We've talked about it in person. I am a solution office. The customer comes with a problem. We solve it. There's no case that can't be solved. I also specialize in building checks. Over the last 2 years, we've done a lot of ATP, which is technical project analysis, checking works under construction, checking projects that were being done, especially complex ones with large spans, large overhangs, pre-stressed works. So we do a check for colleagues who are more beginners and afraid, with doubts, fears, and we do a check to say that everything is okay or that it's not okay, we need to improve here or there. Often the contractor also asks, there's insecurity in a professional who's just starting out in their career. When I started my career, my first client went to do a high-rise building, and he didn't believe I could do it because I hadn't done one yet. So maybe we'll hire a proofreader to give us some security. And that's what we did. And today I do it for other colleagues who are starting out and need a consultant to give them tips. Don't go that way, go the other way. It will be easier. It will be less arduous. And then I end up giving it a certification stamp because there's another more experienced eye behind it. I don't have anything I can't calculate. If there's a problem, there's nothing I can't solve mathematically. I challenge myself to anything. Sometimes it's a mechanical engineering thing that they're calling me about because they don't know how to solve it. And with Vergraf, when the challenge came to use it in the first works, and you still feel it today, it's the fear of using a new product, which you can't even say is new. But for those who have never used it, it's new. So who used me? How do you do it? How can it not be done? But is it reliable? Because I pick it up and break it in my hand. But in reality, the phenomena are different. It doesn't have that effect. So how to use it and how not to use it, I already have several projects built with Vergraf on pillars, on slabs, on glass, on foundations, on piles, on floors, on radiuses. Many, I used it everywhere. But in general, small projects, because the client is always afraid to use it on large projects. But the customer who has already used it once in the next building goes one step further and uses it on yet another item. The guy who only used it on floors now uses it on floors and walls. The guy who used it on floors and walls will use it on piles next time. And then the next one maybe here. Then the client starts to have confidence. They see that it works, that there was no pathology after the work, that it's fine, and if we use it for something else. So I would use it much, much more here, and I can easily convince and mathematically prove to my client that it's worth it technically and economically, and other benefits that we'll talk about later.
He'll keep talking, but I need a break.
But I'm short of products here, aren't I? I'm short of products in the south, aren't I?
Exactly.
That's what I said I was going to tell you on the live stream.
Yes, we have to have a factory right here in the south because Rio de Minas, they can't service Minas, so they can't service us here in the south. And a lot of people ask me for a factory. Today I've been asked by Maranhão, Pernambuco, the whole of the northeast, Paraná, just today, right? And here in the south, we've got this one live now. One important thing you said, Damien, I want to emphasize. You accept the challenge of calculating. There's no obstacle. A calculation comes, you do it, you've said it, and when the check comes, you've accepted the challenge. I want to make a warning, or at least highlight it to the engineers who are going to listen to us and are listening to us. Marcus Adam, he has a really busy schedule. When I say that I've been wanting to talk to him for a long time and he's here with us, it's because his schedule is so tight. And when the person has this attitude that you have, Adam, I do it, I calculate it, and they become an expert. They're not just worried about doing what's normal, what the software does, or what the market already accepts. You yourself, back in 2021, you see Vergraf was still pinching his hand.
It's the yellow one that I still have a sample of to show customers who sometimes don't believe me.
They are evolutions. Vergrafico used to be made with epoxy, better with polyester. Today it's with epoxy. The technology has improved. Pricks more in hand. If you take some normal fiberglass dives, you can't do that here.
That's what you've done now. If you did it the next time, it would sting for 3 days.
Yes, exactly. We couldn't do that here. And now, you see, since that time,
it was one of the complaints of the site staff. They had to use a sleeve for something they hadn't used a sleeve for before with CA50 or CA60. Now with Vergraf, you have to wear gloves. Then you had to say, but it's lighter, it's easier to transport. Then they said, okay then. but I couldn't do it without a glove. Now with this other one that has the tradition, the black roll, the one that you took in your hand, now you don't even have to use it. But now you have to get used to it. It's okay to use it. You've got used to it. You've overcome that barrier.
And we overcome barriers, as you said. First we make a floor, then we make a pile, then we move on to a beam, then we lay. And then confidence grows. And that's what we advise Damo, not least because we don't have the product to deliver to do an entire job.
And then it starts, I already have a 4-year track record of work that you can go and, so in perfect interviews and so on, people, oh no, well, now I believe, now I trust, right? St. Thomas, right?
It's true. But there's this side to it. People want to work with innovation after everyone else has already used it. I said, no, it's not innovation. For you yourself started the live by saying here, no, but he's not so young anymore. For you, it's already a 3-4-year-old product. And for someone who's just getting to know it, it's still new. And you've already used it. You've already calculated it on stakes, on...
I even looked it up here in the history, if you were to ask. Where I used it most was on floors. Industrial floor, garage floor, gas station, radius foundation, and footings. I've used it on piles too. I've used it on curtain walls. The advantage of Vergraf is that you don't need such large coverages for parts in contact with the ground. A very cool one I used was in a sewage treatment plant. Super aggressive environment. We did everything with Vergraf because then the cover could be smaller and the pieces were slimmer in concrete. It was very interesting, and one of the first places I used it was in my beach house because I didn't have any clients wanting to use it either. I had a fence post and Moe Rose on the coast here, which is very aggressive near the, practically on the seafront, right? Every 5 years we have to repair plaster and concrete that's cracking, bursting, and corroding. I redid everything. The posts, the vines, the balcony, all with graphite. Due to corrosion.
And that's where I start. The first experience you had was already gained. Look, it started in your own work in the house, on the wall.
Yes, for a small item, the house was already built many years ago. I wasn't going to do anything, but now I've done a renovation. I'm going to change the whole fence, the posts, and I'm going to make it in concrete again, but not with steel. I'm going to make it with. And he got it right. The wall is still there today without a crack, without...
I'd like to invite everyone who's watching us, if you put the city you're watching in there so we know who's talking to us, and you can also ask questions. For example, Lucio here is a Radware Graphics ex-partner. He's with us a lot in our communities here. He asked a question, obviously in more detail, which is what most people ask. It's, let's say, the big question that everyone wants to know. There is a lot of talk about the modulus of elasticity. Could this be a problem with pillar use? No easy questions, just ask. At this point, what do you have to say about it?
It varies by case. If it's a heavily loaded or very slender column, you'd have to review the calculation very carefully. I've also used it in slabs, but always with small to moderate spans because of the material's lower modulus of elasticity. So in my cases, when I went for a longer span with a bolder and more complex structure, I didn't take any risks. I used CA50, the traditional one or protection. I didn't use Vergraf. Because there you would have to do a much more complex calculation, and the deflection would result in a higher value, and it's already a more slender and critical piece. So we're going to use a more traditional structure because the lintel isn't meant to replace everything on site.
Exactly, it's perfect.
So slender elements that require greater care in terms of horizontal deformations in the case of pillars or buildings, or vertical deformations in the case of slabs, overhangs, I don't use for this reason. But if it's a small overhang, a small gap in the slab, a normal column height, not so heavily loaded, then there's no problem. I can use it as I have used it. I've already used it. You know that here in Novo Hamburgo, we had the privilege of having the Mostra glass, where many prototypes of houses were made. And to this day, they are changing the decorations to get involved. To advertise architectural and design products, the houses were made with Vergraf to also introduce this to the market, to serve as an advertisement, a model and a prototype.
I recall a comment.
These houses, the pillars were used, rebar was used in the pillars, in the beams, in the cover of the precast slabs, prefabricated slabs and so on. Of the mesh, of the cover, it was with Vergraf. Most of the items of lesser responsibility, or when it was an item of greater responsibility, such as a pillar or a beam, the spans were moderate, small, 3-4 meters, where the deflection calculated by the traditional, conventional method with CA50 resulted in 0 point something centimeters, well below the tolerance. With Vergraf, it will also give 0 point something a little more, but well below the tolerance as well. So it's not a problem. The problem with using Vergraf with a much lower modulus than steel is in very slender or highly stressed parts. Then I wouldn't recommend it. Start with the traditional.
I still remember you talking once in a comment with Noto, like, well, I made a wall here, I used it, I just didn't use 100% Fregar because I didn't have the fold yet.
Yeah, that was important too. We didn't have it at the time. We still don't have it, right? Soon there will be, won't there? The stirrups, using the stirrups would be very interesting, right? But if we didn't have the bending, we limited it. We made the longitudinal reinforcements with Vergraf and the stirrups with 5 CA60 or 6.3 CA50 diameter bar. Yes.
Yes, I remember you built a retaining wall here too.
I was able to take Vergraf's 4mm wire and make a helical stake. Then he held on. Then on the pile, we used a helical weave to act as a stream. But in a 19 by 40 beam section, the bend needs to be rectangular. So we didn't use it. Yes.
Look, you've already innovated one more item. I don't think we've even publicized it yet, that you've made a spiral stake with a scroll as well.
Yeah.
That's nice.
That roller at the back is 8 millimeters. He makes a circle with a diameter of 1 meter, but with a 4 millimeter or 5 millimeter gauge, I was able to make a diameter of 30 millimeters, and then he makes a very nice equidistance to put inside the pile. It's just a pain to assemble because the guy is assembling the spring, and if he slips, it comes loose. It's a real roller, so he has to assemble it carefully and tie it off, but it works well. For those who want to try it out, do the experiment. Then use it in the longitudinal reinforcement and make the normal conventional stirrup, bending it, making it on the building site, or having it cut and bent at the plant without any problem. I was just starting to use it. A good place to use, do you know where it is? It is not an element of great responsibility. Easy to change the CA50 or the welded mesh for the mesh or the verge screen. A good place to use without fear. Another interesting place is in the skin armor of the beams. Because it is straight, thin, low possibility iron, where there is only attraction, where the material can give the best performance of all. So it's a good place to use stakes and flooring. Flooring is where people end up using it the most.
So much so that we can only deliver knitwear from December onwards because production can't run until December. In the mesh part, rebar still manages a little earlier. I have another question for you here, which Lucio also sent. And if you're watching us live, enjoy it now. Adam has to leave in a bit. There are people here, Adam, watching from Teresina, Rio de Janeiro, São Paulo, São José do Rio Preto, Araruama em Rio de Janeiro, Vitória, Espírito Santo, Teresina em Piauí.
Piracicaba POI staff, many have already called me to ask questions. I think they're promising. Several people called me from there to ask questions about this, that, and how to do it. They're really interested.
No, the coast there is very strong, and we really need the factory there too. Here now, John is also saying hello. And in Piracicaba, we're going to have a factory soon. It opens at the beginning of the year. Limeira too, São Paulo, another factory. Goiás is opening another one. Brasilia, one more. And soon there on the coast of the Northeast, but hopefully soon here in Rio Grande do Sul for us too. There's a factory that we've managed to get more of in the works here too. Lucio's question here, is it possible to use it in lampposts? What is your vision for this application?
Yes, of course. It's a good place to use precast post. It's very interesting to use. Durability, right? We see a lot of poles in the area bursting with concrete, corroding steel. It's a place, helical armor or even with a screen, right? And the main bars, entirely possible. And if you're in doubt, you can do a load test. I'm planning to do a play myself. Put it on, subject it to continuous charging, and leave it there. This piece here was made from steel, and this one next to it was made from Vergraf. Both of them have a known load being applied continuously between two supports to monitor the behavior. Can you see that this one has deformed more? Do you notice that the other one is more deformed? Do you see that both have deformed similarly? To make a small part, you have to do a load test. People ask a lot of questions and have a lot of doubts and fear. If they have a little bit of fear, we suggest this to Manuel, and he even makes a few pieces there and puts the foreman in charge of the yard of a factory with steel, letting the bar come out of the steel, even showing the steel, seeing that it's already corroding, seeing that the other one isn't corroding, seeing that here it's longer and yet it is. The other one is shorter and deformed similarly. Load proof, Daniel. There's a client of ours. There are many people who don't trust the calculation very much. Well, I trust him, but he's...
You have to see it too, so I'll show you in practice. We had a client of ours buying Vergraf make stairs. So the bases, he put in concrete on the stairs, which would be small pieces, similar to the cell phone here. And we started jumping on top. Even he made it in his factory. We put it there. At Vergraf, and everyone jumped and stepped on it, we put two supports on the side. And with Vergraf, he flexed and came back, 0 cracks. And with the steel, the plate began to bend and crack.
It's fatigue.
It's fatigue. And then in practice, in a simple test, people began to see, well, really now,
it's a load test.
So we did it there at the farm, including the last live I did. I went and jumped on Monstret. And the fear still, those who are heavier don't even jump on steel anymore, right?
If you have that, clients ask me for that kind of thing. Since I didn't have one, I'm going to have to take a karma test. It'll be ready soon, right? There's no need to invent something that's already been invented.
That's right. I'll send it to you, and I'll also put it on our media, and it should be there somewhere too. But on the 27th, we're going to be at Bifibra. Bifibra is going to use full camp to give lectures on the use of GFRP rebar, not just Vergrafs, so all polymeric bars. This in the morning on the 27th, and in the afternoon it will be there at Unicamp's laboratories doing these tests in the lab. So there are already a lot of people invited to this event. I think the tickets or invitations are already sold out because it's not a ticket, and it's on the 27th, and we're going to broadcast it live. So there'll be lectures there. I don't know if we'll be able to broadcast live from the lab, but at least we'll broadcast the results or some photos, and we'll give everyone the security you have today, right, Adam? You have it because you said so. You know how to calculate, and you trust the calculation, and you've already done the tests. You've started from the wall to the...
The bar itself has many tests and laboratories and everything that is. The university has already shown that it has a standard that you can rely on. So in order to apply this, trusting the bodies that have already certified the material You have to use the mathematical equations of the standards and put this into practice. As the work goes on, there's history, there's feedback, there's a crack appearing. Let's see why. And whether it has to do with the material or not.
Here they asked 2 more questions. I don't think it's for Adamy. I think it's more technical here about the product. But Adamy should also know, because he knows the product. Can it be pre-stressed? Can it be pre-stressed? Can you tell me? I think the product does, but I don't think it grabs there.
I'll have to do some tests. I haven't seen any tests on the wedging pressure on the guts plates. If it's adhesive protection, I'll have to check the adhesion itself, because the coefficient of adhesion of the material is slightly different from that of steel. But perhaps using prefabricated drop slabs with protection was even a question of doing load test trials.
I spoke to our engineer there.
I'd say it's in its infancy today, but in a year or 2 there will be tests to confirm this.
That's right. The challenge is more in the encouragement itself.
When it's non-stick protection, which we're more used to using
It was one of the questions I was going to ask.
Because the advantage of the material, sorry for cutting, as it comes in a roll of 100 meters, and the CA50 bar is 12 meters, apart from the thin wires that could also come in a roll. The fact that it has no splices is interesting for very long pieces.
It's true.
And for protection, we use long ropes without splices.
And in this case, it's also an opportunity that the market brings, right? Whoever can adapt the product to their needs.
I think it ends up having an advantage. But there's a lot of work to be done before we get to that point. And I think it's a step beyond what we need today. But of course, for those with a more advanced vision, you can consider it.
Going out with 15. No, that's right, because I also advise a lot on this point. I want to exchange the entire work for Vergraf. No, start by building up your confidence.
Today, we can't even do some things.
Depending on the project, we don't have the bend, so we start there.
You need to make a large knot with a beam anchored to a pillar. You need to make a bend. You can't do it. The folded stirrup itself has to have a machine that can do this while the factory is running at speed. The folded element, and then harden it to the standard size, because otherwise it's a bend that you'll have to make on site. There has to be equipment on site to heat up the bar, free it, then cool it down again.
And there's nothing wrong with mixing, is there, Adam? Mix the 2 materials, they behave.
It's also delicious, no problem. When I did my work on the beach, I didn't want to use recessed wire to bind the pieces of glass because, well, I'm doing it because of corrosion. That was my main reason, which was to avoid corrosion. But then I'm going to bind the bars with wire, then the wire will corrode, right? Yes. That plastic cat hangman, right? Then the bricklayer thought it was bad, right? With a glove, you have to keep moving around here. It's hard to get it in, isn't it? Like threading a needle, right? Complicated. So I bought aluminum wire.
Interesting.
1 kilo solved everything. Small pieces yield a lot, right? Then he would tie the knot between, I would attach one bar to the other with an aluminum because of the concern about corrosion, right?
Great solution. Today he doesn't need the glove so much because before he had to wear the glove.
But then you can use the plastic clip, which we here in the south call a cat clip. People in Rio Wiese call it that.
They'll think we're out of line here. But it's not, it's just the way we talk here. But I think it's the plastic belt, which is called, but
it's the one at the back that you can hear. Here, look, I'm tied up here.
And there are many opportunities. I see that, and it's a question I was going to ask you. I see the opportunities even more for engineers because we depend on the talent of the engineer to be able to size the work, to make the client have more savings, more efficiency, and the engineer knowing how to calculate can gain added value. Have you had these experiences of getting this added value for yourself on site?
No, not yet.
Did you do more work for yourself?
No, I did it more for personal reasons, to have the knowledge so that when I really needed to, I'd know how to solve it. For my client, I want to use it, do you think? Yes. The only thing I can say is that I know how to solve it. I don't charge anything extra for it, and I haven't won any more clients because of it. 1 or 2 consultancies and so on. But since here, specifically in the South, we don't have a lot of products at our disposal, I could have done a lot more calculations and maybe even used them to my advantage. Like, I need to calculate an entire Vergraf project, but there's no one to calculate it. Adamy in the South calculates. He charges but so much. Anyway, I could get more out of it, but not today, because I also started with you back then, believing in the product, investing time. Money too, to know, understand, study how it calculates, how it doesn't calculate, how it has to do it, how it can't do it, how far I can go, how far I can go. Many hours then researching and understanding how to do it, so that today I know how to answer the questions and have mastery of the material to know how far I can go with the safety coefficients of the standard, etc.
Today, Vergraf is at a level where it needs more factories, especially in various parts of Brazil. Speaking of the South, and we want it here, but in addition to the factory, because it's a demand that comes with more production, more factories, people need to scale more. So it's a lot of work that's going to come in for Adam and all the other partners.
It's only a matter of time before the universities teach this in the calculations, the norms are put in place properly, the rules, everything. Everything is on track, right? Some things take slower steps, some things we're ahead of, others will take a little longer to arrive.
But only a few people will really be able to stand out in the market. Just as you already have a strong name here with Vergraf, with us, and with several clients. But when I talk about having a benefit, it's like you said, maybe we don't even need to charge more, but people come to Marcos, not just because of Vergraf, but because he knows how to solve problems. Vergraf is one of them.
That's it. As for that, yes.
That's the big difference. When I say that, we have a group called Vergraf X. The X of the question is the professional, because if they know how to scale, they will have opportunities. If I'm going to have someone do my house, someone who brings me solutions like Vergraf, who will size it differently, will reduce corrosion problems, will reduce lightness in the builder's practicality. So I have more confidence in this professional. He doesn't even have to charge me anymore. He'll always have the service. And like it or not,
he's going to tell the other guy, he's going to spread the word, he's going to go there, he solved it for me, that guy solved it for me.
That's right. I have a few more questions here that I'm going to ask Adamy, and Adamy will be right back. I'm going to get Junior to talk to us here too, but let's see. I think there are a few more here. You're being asked about compression tests, but I think it's part of Vergraf. We've already done compression tests, but what can you say? It looks very similar to concrete.
The labs have all the tests, right?
Yes, we do.
Traction, shear, compression, the results, some superior, some inferior to steel. And based on this, you have to calibrate your calculation methodologies to E.
This week, everyone stay tuned to our website, Instagram, and Technobra. A new manual is now coming out that has all this information more summarized, easier for everyone to understand. Because before it was too long, people were looking at a very long manual. Today, we've summarized it in a way that makes it easier for everyone to understand. Here, it's more. How many floors could I make by completely replacing the steel with fiber or overgraph without having problems with the structure? Jefferson asks from Rio de Janeiro, if you were to change everything, what kind of house? 1, 2, 3 floors? I believe that's his question.
Look, technically, I should answer that there is no limit. If you supply me with the stirrups folded to the gauge I specify and all the parts in the size of the gauge, we can substitute 100% and there is no limit. the building has, now let's get into the specifics. The pillars have to be small in section because it will interfere with, then the limits will start to appear. So on that pillar, I can't use it. That the modulus of the area of the material will prevent it from having the same characteristics as another pillar of the elevator station, which is larger and has more sessions. So there will be a differential deformability between one and the other. But if I have carte blanche to put the session I want on the pillars, the commercial building, for example, regulate the size of the pillar so that the turnstile doesn't enter a regime that requires its velocity module to be limited. I can use what the material has to offer me without exceeding certain limits, then I can use 100%. If I can limit the size of the slabs in a span so that it doesn't affect the deformation limit that the standard prescribes, I can use it 100%, but that doesn't exist. That's one thing. A utopia, right? Because buildings have many peculiarities. You'll have a balcony with a large span. You'll have a slab with a large span. You'll have a super loaded column with a much higher compression rate than its brothers next door. In these, we will use conventional steel. For the rest, we can use it. And it's not your idea nor mine to want to replace it 100%.
No?
No.
He can't.
Because if the cost is much better with Vergraf, we'll want to replace it 100%. But today the cost is very compatible. It's almost exchanging 6 for 612. So I'm going to use Vergraf. Why? Because it's lighter, it's easier to carry. I take it from one floor to another. When I built my beach house, I put 4 rolls on one shoulder and 4 on the other. Look here, I'm carrying 800 meters of rebar. I didn't say it was rebar, did I? I gave your avocado to the council. A lot of form. No, it's the lightness of the material. So the logistics are much easier to load. That welded one, you'll have a crane to take it up there, yes, but how many canvases do you take at a time? The guy puts that roll on his shoulder or 2 and takes it upstairs. And if it's with GRU, it's good. It takes 6 rolls upstairs at once of a floor. So the logistics became much easier. The issue of coverings, you just have to take care of the fire issue, maintain coverings if the building requires fire resistance sizing. Then you have to keep the coverings on. And the rehearsal for the fire is also something I'm waiting for. Then there should be that too, so that those answers can come too.
There are tests on firefighting material. The Vergraf tests and several other institutes are still in the process of being drawn up. Any other questions? Go to the closing as well. Then if Junior is watching, ask him to come into the meeting, since I've already called Junior. And the question is, what was your biggest difficulty in starting calculus at Vergraf?
Mathematically, he's asking, right?
Probably. What was your biggest difficulty when starting calculus? I think it's at the beginning.
That's because we have the data. How much traction can it withstand? What is the mode of elasticity? But what about the equations? How does it work? The equations are not all the same as for steel, whether it's A50 or A60. And fundamentally, the starting point was this Ibracom manual reinforced concrete structure with fiber reinforced polymer bars, which was the draft standard. Can you see this manual here?
You can see it. It's perfect.
From Ibracom, it's the starting point. Because here it shows what you have to consider, the diagrams, bending, deformation, the material resistance curves for various types of fiber, some equations, safety coefficients that are different and are higher than that of steel, also because the product is still new. So the standards, for political reasons, the safety regime, they came up with higher safety coefficients than those of steel. So all this comes here. It's not very chewy. You can have a good starting parameter to guide you and make your own positioning. I set up my first Excel spreadsheets with the calculation step by step, a beam on the side as if it were with CA50, comparing what happened to one, what happened to the other, so that I would have mastery, so that I would know what I had in hand, what would happen if the volume increased, what the influence of the modulus would be in an X or Y situation, then for columns, etc. Then I calibrated my own software with these figures to give me the results that market software doesn't yet provide. Exactly. Just change the material and it will self-calibrate. To do this in my own reinforced concrete software with traditional steel and calibrate all the parameters to use Vergraf.
People have asked about the Ibracom guide. They're asking again here to show it to you. And we can also share it in our group. I'm going to share the link where you can buy it. There's a guide you can buy from Ibracom.
Yes, it's very cheap and the material is very interesting.
Show the cover so that people can see it again. So that people understand that if they buy it on the website, if they go to the BS or Ibracom website, they can also access the guide of practical recommendations.
I'll show you here. There are examples. There are essay examples. There's mathematics here for those who like it. There's all the data. There are my notes here. It's good material for those starting out. It's the material I recommend. It's in Portuguese. You don't have to look for a foreign standard. You don't have to worry about translating. I've already searched for some foreign standards to compare some equations, some forms that I was finding, suspecting that I wasn't right here. I won't check the foreign standard. Then it changed. Small parameters changed, so it's okay. But it's curious, really. Here it shows how to calculate the safety coefficient, if it's a part in contact with the ground or not in contact with the ground, which safety coefficient to adopt, which ends up reducing the capacity of the material, which is much higher than that of steel. But if you use a higher safety coefficient, you end up pairing the fight. That's why you can't, I always criticize Manuel a lot. He always said that our material can withstand twice as much. Yes, but when you calculate on paper, you can't use everything the material has. Please, you have to respect the norm. No, Manuel, twice as much. It's not like we're going to tie a piece to one car and you tie it to the other. We're going to pull it. Which breaks first? Vergraf will win. No, but if you add the little safety things, you can't use everything the producer has to offer. Just as the Artio is 1.15, the Vergraf will be bigger, right?
It's to be going bigger.
I'd written it down. Let me see. It could be 1.63, 1.8, depending on the situation. It's much bigger.
Today we already have tests. We used to have tests of up to double traction. Today in the new test, it already reaches up to triple traction in most gauges. So we're also increasing. We've increased the modulus of elasticity a little. We've been improving the product.
Yes, at the beginning we had 50. I think it went up to 80 a year or two later when they changed the resin.
He's getting better. He's improving little by little. There's still a long way to go as far as steel, but it's not our competition with steel.
No, and you don't have to either. You don't have to.
That's not the case.
Junior arrived. Can't you answer that necessary slice of the market?
To understand, look at Marcos. We did a calculation. If in the next 10 years we have 150 factories in Brazil, all working at their maximum volume, we will compete there with 10% of the steel market. So that's a lot of factories to compete with 10%. I can't even mathematically, at least for the next 10 years, compete. I don't want entire works. And the trend is that the level of construction will increase a lot and the number will be different in the next 10 years. We also have to understand that there's aluminum, there's wood, there's acid, there's glass. There are various complements that a good engineer, a good architect will know how to complement and know where each material is best suited. No work is done entirely in one type of material, the composition, and we manage to compose very well with steel.
There will be cases where we'll want to use 100% because it's a sewage instrument station. As I gave the example, we wanted 100%, but then we didn't have stirrups. It was a floor, a wall, so it was just a screen. We used it. We calculated the necessary steps, so we were able to use almost 100%. As there was a longer span that had a pillar, we made the pillar out of steel reinforced concrete.
People are also using Vergraf a lot now in agriculture to make grapevines, strawberry vines, the arches like the ones here to make strawberry. Vines, because steel rusts a lot, it stays in the weather, so they found it and it's a huge amount, right? So you see, you come up with new uses, applications for the product. Well, we're going back to the Marcus Adamy era. Junior is here with us. Do you have any questions for Marcus, Junior?
Good evening to you. Thank you for your participation. Adamy, I found what you were saying about the condition of the calculations very interesting. We can't really unify this into a supergraph, can we?
Right.
When you started and managed to do this, did you set up commercial software or your own software, your own spreadsheet?
Both. When I check a few individual parts, I use my spreadsheets. In Excel, I can keep track of what's happening. I can quickly compare whether it's steel or videographic. Now, if it's a larger project which requires more sophisticated calculations and methodologies and more time-consuming mathematical processing, a flat slab, I need to do a calculation using the finite element method or a grid I need to calculate the forces. Then I necessarily have to use the software. Then I calibrated it. I used TQS. I calibrated its parameters for the verographic material. And I still do some locating, some spot checking of the most critical parts in my spreadsheets. A column, a punching shear, a bending limit, a section of the slab, the critical points, to see if the results match what I expected. So as not to take a false step.
Do more math. I'm trying to do this in CPCAD.
Even in a traditional calculation, the software sometimes gives you some results that you have to question. There's something that's not out of the ordinary. Given our experience, I expected a different result. Next thing you know, you've made a crimp where you shouldn't have. With a joint where it shouldn't have been, with the little spring cartridge in a foundation that caused an unexpected settlement because it wasn't properly calibrated within the calculation model, the software. Even if you don't use Vergraf, you may be surprised by a result that isn't real. It's even more of a Vergraf. It's newer material. It's recent, so we have to be careful that it's not making a mistake. You have to use both in parallel, software and separate, occasional checks only with the results of the software. Because you can make a whole model in the software just to find out what the moment is, what the normal is, what the cutting edge is, and with these numbers calculate the specific part. The software helps you a lot with detailing. Everything has already been detailed, the folds, the stirrups, the distribution. Yes, but the result of that piece is correct, so it's good to check it in a separate spreadsheet or hand calculation to make sure everything is correct. Then you can trust me.
So I'm thinking in the right way. I'm trying to do this kind of analysis that you've already done in TQS. I'm trying to do it in CIFICARD. So I'm taking a very close look at these points so that there's no mistake. Because sometimes, most of the time, we see a lot of software pilots out there just putting in information, taking out the result. It's somewhat risky.
But people who are more inexperienced, who are just starting out, should look to someone more experienced for advice, for verification. I have a lot of newcomers who come into my office and I say, I can pay you for an hour's technical consultation so you can see if what I'm doing is right. Let's go. I needed help when I started, so I don't shy away from helping anyone who's just starting out to do the right thing. And people who have more experience, just by looking at it, already know what's right, what's wrong, what's the critical point, what they have to take care of, what's less important, what they can trust more in. the software, what he can trust less, that sometimes he gives you a result for a footing. It's 8 20-millimeter irons that can't be right. A tiny footing for that load, there's something wrong. When he sees it, he's got a unit wrong, or he's put the concrete at 20 kilos per square centimeter and it should be 20 megapascals. You know, that sort of thing. Because if you lose that many numbers to fill in, you've made a mistake, right? And I'm already looking in my engineers who work with me, when they give me a project, I check it, I see straight away, this is wrong. You can look there, there's a mistake here. Said and done always. Either it's not calibrated properly, or it's put on a load that was supposed to be 15 kN, but it's put on 15 tons. Classic mistakes sometimes, right?